Hi then. So today we're going to solve the question longest substring without repeating characters. And alright, so the question it's about having a string and and getting the longest substring that there's no duplicate without repeating characters. So if we look at this example, ABCD, ABC, ABCBB, your substring, basically substring is just a part of a string, a portion of a string. So A is a substring, AB is a substring, ABC is a substring. Now, if you take the longest substring, if you are looking for the longest substring, the longest substring is can be ABC, because by the time we include A, we are having repeating characters. So the longest substring can be ABC. It can be BAC. It can be CAB. It can be CABC because of by the time you include C, you're having a repeat character. It can be ABC again. It can be BC, but BC is not the longest because of we have a substring of 3 already. BC is just 2. CB is 2. So the longest is actually 3. ABC or BCA. That's the longest. For this, our answer is just B because it's just 1. Because of BB is already repeating. So you can just have 1. And for this, we can have PW, that's 2. It's not the longest. We can have WKE, that's 3. That's the longest. We can have KEW, that's also 3. We can have the longest. So basically, that is it. So how do we solve this? Let's write the first example. The example of okay, let's go to the side. Sorry. Example of A B C A B C B B. One way we can do it is we can use brute force. So we can have a for loop that loops through everything, and then have another for loop that checks for when we have a duplicate. So we can have something like a result, and then we can have a for loop that checks in the string. Then have another for loop that starts from I plus 1 to the end of the string, to the end of the string, to the end of the string. And in it, we will be increasing our, let's call it V. We'll be increasing our V, and we'll be increasing our V, so we'll be adding to our V. So we'll be having AB, ABC, AA. And anytime we find out that we get a repeating, we will break from it, and then would get the maximum amount. So we'll have AB, ABC, AB. By the time we get to AA, ABA, we break, and then we start from BC. By the time we get to BCB, we break. Then we have from CA, CAB, CC, we break. ABC, we break. This kind of solution will give me an O of n square solution. O of n square solution, which is okay, but you know, the brute force solution is not always the most optimized solution. So is there a better solution? Is there an optimized solution? Yes, I think there is. Actually, there is. And this is called sliding window technique. We can use a sliding window technique. And the sliding window technique is just a window in a string. So A B C B. It's a window in a string. But this window is not a static window. It could be a static window, a dynamic window. This window will keep increasing and decreasing based on your condition. So you can have the window like this, and then we can increase the window to increase the next one. And then we can increase the window to increase the next one. Then we can increase the window to increase the next one. And then we can probably reduce the window. Maybe we can probably reduce the window like this, or reduce it like this. That's what a sliding window is, basically. So how do we use the sliding window to solve this particular question? We have A B C B B. Well, we can start by having a window of starting from here, window of year. So at every iteration, we want to increase our window, but then we want to stop our window when there's a duplicate. So we can actually keep track of the position of window with like a left at 0 and a right at 0. So at first iteration we'll increase our this thing. Okay, so let's call this content of the window. So our window is nothing, but then on first iteration our window would only include a, so our window will be like this. On our next iteration our window becomes like this. Our next iteration our window becomes like this. Now on our next iteration, before we include our window, we check that before we include the next in our window, we see that a already exists. Sorry, before then we see that a already exists in our content. Because of a already exists in our content, right, we don't include this in our window just yet. Well, you can do it in two ways, but let's say we don't include it in our window that yet. Would decrease our window until a doesn't show up again. So what we'll do now is we'll now decrease our window. So our window now becomes this. Our window now becomes BAC. So A is no more in our window, right? So since A is no more in our window, we can now increase our window to BAC. Okay, mind you, while we're doing all this, we'll keep track of the longest. So far we have 3. Now we have BAC. A. At this point, our left has moved to our left index has moved here, and our right index has. So this is our left now, and this is our right. Now the next time the next iteration we want to include B, but B already exists, so we'll decrease our window again. So left then comes here, then we increase left, then right comes here. So our window now is this portion. Sorry with the jargons, by the way. Our window is this portion, right? Then we want to go to the next portion. C already exists, so we cancel C before we now include C. At this point, we're also keeping track, theory, and then theory again. So right goes to the next one, left comes here. So we have ABC, then we include B again. By this time, at the time we include B, we're going to have to reduce our window until B doesn't exist again. So we have to remove A, remove B. So B doesn't exist again, then we now have B. Then at this point, our left is at this point, and our right is at this point. So we increase our window one more time. So we include it like this. So we have left and right. But B already exists, so we have to decrease again before we put B. And that's how the sliding wheel works. I will do one more example with it, and then write the algorithm. So let's do the for PWW KEW. I'll try to make this one a bit clearer so that it's easier on the eyes to see. PWWKEW. Okay, so let's go. We start with our left and right at the same point. We start with our left and right at the same point. We have our content. We have our results. So at this point, left and right, our content is only P. So then we go right becomes here, and PW. Okay, right gets here, but since right gets here, W already exists here, so we'll cancel from the back. So we move left here, we cancel. We also move left here, so we cancel. Then we now include W. At this point, we've already gotten a result of 2 because of left and right already has a 2. So now we have right here, left here. So we go right here. When go right here, content becomes WK, right? WK is 2, so our result is 2. Our maximum is still 2. Then we go here, right comes here. When right comes here, we have E here. Now result becomes 3. Then right comes here. When right comes here, because of W already exists, we need to cancel from the back. So left will move to this place. We cancel it. By the time left move to this place, we've already cancelled our W, which is KE. Then we can add W to the back here. This is KEW, and we still have 3. So our maximum substring is 3. Yeah, so now let's try solving it with code. Okay, so the first thing probably want to do is we want to say our answer is 0. We want to establish our answer, result is 0. And now we want to put out our left and right because we want to take note of it. Now we want to keep looping till, in this situation, we loop till the end of the counter. So we want to keep looping till the right is less than the length of the string. And while we're looping, we want to get the value of the, let's call it the font. Let's call it the font var. We want to get the value of the font. The value of the font is the value of x. And then we want to know if the font var is inside our content. Value is in our content. But we've not defined our content. So we say our content is, well, I can use a string, I can use a dictionary, but I'm going to use a set because of I want to only store the content only once. Well, yeah, so I can do something like this, right? And I want the lookup time to be of 1, basically. So if font value is in the content, if the font value is in the content, what do we want to do? At this point, we want to first of all check our results. So we want our result to be the maximum of the result and the length of the content. Then we now want to start removing from the back. So we're going to do while the left is less than or equals to the right, and and the font value, and basically the font value is inside the content. So we want to keep looping as long as the font value is inside the content. We want to stop looping. Basically, we want to cancel out to the point in which the font value is inside the content. So when we get, for example, when we get to this W, we want to keep canceling until we cancel out the W's. That's it. So we want to keep canceling. And how do we cancel? We do content dot remove. Now remember, we're moving from the back. That's where the left counter comes in place. We're moving from the back, so we want to remove from the back. So we keep removing from the back until I want to remove her. We keep removing from the back until we get to the font value is no more inside the content. And at this point, we're out of the loop. Now at this point, we want to increase the value of L. And we want to increase the value of L while we're looping, so that we cancel from the back, then we cancel from the next back, then we cancel from the next back. Then in case if font value is inside the content, or if it's not inside the content, what we want to do is we want to now add the new value into the content. So we want to add font value now inside the content, and we also want to increase the value of 1. And then after everything, we also want to find the result again by finding the maximum. So we want to know the maximum between the content, what is in the content, and the result. Why? Because we might have a situation in which we have ABC. Where's my pen? Okay, sorry. We might have a situation where we have A, B, C, D, where the whole string doesn't cancel. The whole string is not repeating. In this situation, if we don't include this, we are not going to eventually count what is in the content. So we want to count what the content at the end, and then finally we want to return the results. Okay, so let's see if this works first. Okay, test cases passed. Let's submit if it works. Yep, it works. Okay, awesome. So let me just try and explain one more time. So what is going on is we have our results where we are storing our results. We have our content to know the values of what is in the window at that point. We have our start window, the beginning of the window, the ending of the window. So we are looping through this the string, going from increasing the window basically. At every time we increase the window, before we increase the window, we want to first know if the value we want to increase already is in the content of the window. If it is in the content of the window, we want to first of all store the maximum value because we're going to start popping out. So let us first know the maximum value in that content. And after knowing the maximum value in that content, we will now start popping out from the back. We pump out from the back until we get to the value in which the window was about to adjust to. After you pop out to that extent, you now add the you add to increase the window, and yeah, and you increase the index of the window, and that's it. That is how we solve. That is how we solve the longest substring without repeating characters. Thank you.